question from JEST 2016, where we are given a wave function of hydrogen atom which is a superposition of psi n L m, and we are asked to find the expectation value of energy, ratio of expectation value of energy to ground state energy, and also the expectation value of L square. So let's do this question. Expectation value of an operator A is defined as expectation value of operator A. This is equal to summation over n Cn mod square An. Here An are eigenvalues or outcomes of operator A. That is, if we have operator A, it acts on psi n, then we will get some constant An times psi n. These are called eigenvalues. These An are called eigenvalues. Now this formula for expectation value of operator A, this is applicable if psi is normalized. If the given state is normalized, then only you can use this formula. Otherwise you will have to divide by a summation over n Cn mod square. So let's check if psi is normalized or not. So if we take this sum of modulus square of all the coefficients, if it is equal to 1, then we say that psi is normalized. Psi is normalized. So in the given question, C1 is root 2 by root 7, C2 is minus 3 by root 14, and C3 is 1 by root 14. Therefore this sum will be equal to root 2 by root 7 modulus square plus this is C1 mod square plus C2 mod square will be minus 3 by root 14 modulus square plus 1 by root 14 modulus square. So this is C3 mod square, this is C2 mod square, this is C1 mod square. There are 3 terms, so summation will run from 1 to 3. So let's check if it is equal to 1 or not. So root 2 by root 7 modulus square is 4 by 14 or 2 by 7 plus 9 by 14 plus 1 by 14, which is equal to 14 by 14, which is equal to 1. So summation over n Cn mod square is coming out to be 1. So psi is normalized. Therefore we can use the relation. Therefore we can use this relation. Expectation value of A is equal to summation over n Cn mod square An. So let's find out the expectation value of E. Expectation value of E is equal to E1 C1 mod square plus E2 C2 mod square. So E1 and E2 and E3, these are the eigenvalues of energy operator, plus E3 C3 mod square. And for hydrogen atom we know that En is equal to minus 13.6 divided by n square in electron volts. Therefore expectation value of energy will be equal to E1 is minus 13.6 by 1 square, which is minus 13.6 itself, times C1 mod square is 4 by 14 plus E2 is minus 13.6 divided by n square. N is 2, so minus 13.6 divided by 4 in units of EV times C2 mod square. C2 mod square is 9 by 14 plus E3 is minus 13.6 divided by 3 square, which is minus 13.6 by 9 times C3 mod square is 1 by 14. Therefore, expectation value of E is equal to, you can take minus 13.6 by 14 common, and inside we will have 4 by 1 plus 9 by 4 plus 1 by 9. Which is equal to minus 13.6 by 14, 4 into 9 divided by 1 into 9 plus 1 by 9 plus 9 by 4, which is equal to minus 13.6 divided by 14 into 36 by 9, 36 plus 1 by 9 plus 9 by 4, which is equal to minus 13.6 by 14 times 37 into 4 plus 81, which is 229 divided by 14 into 36, which is 504. So this is the expectation value of energy, minus 13.6 divided by 14, 229 divided by 504 electron volt. Now we are asked to find the expectation value of ratio of expectation value of energy by ground state energy, which is E1. So E1 is minus 13.6 electron volt. So if you divide by minus 13.6 electron volt, what remains is, actually this 14 is not here because we multiplied inside, we multiplied 14 by 36 and then we got the answer to be 504. So this is equal to 229 by 504. Let's calculate the expectation value of L square. So this is equal to, eigenvalue of L square is, when L square acts on psi n L m, it gives you L into L plus 1 h bar square psi n L m. So this is the eigenvalue of L square, and it is decided by this thing L. So C1 mod square is 2 by 7 times eigenvalue from the first term. So eigenvalue from the first term, in the first term L is equal to, in the first term L is 0, in the second term L is 1, and in the third term L is equal to 2. So from first term the eigenvalue is L into L plus 1 h bar square, which is 0 into 0 plus 1 h bar square, which is 0, and from second 1 into 1 plus 1 h bar square, which is 2 h bar square, and from the third it is 2 into 2 plus 1 h bar square, which is 6 h bar square. So these are the eigenvalues of L square from each term. Therefore expectation value of L square will be equal to 2 by 7 into 0 plus C2 mod square is 9 by 14, 9 by 14 into 2 h bar square plus 1 by 14 times 6h bar square. So this evaluates to be 12h bar square upon 7. So the correct option is option A.